Hello, ladies and gentlemen. Welcome back to math. Today, we're going to be dealing with a specific shape, okay? When you see this specific shape, okay, you guys think of a ball, right? It is a ball. In math, it is known as a sphere, okay? It's three-dimensional. It's a circle that is three-dimensional, okay? It still has a radius, okay? You just don't see it, but it still goes from the center to one of the edges. If we cut this in half, it is known as a hemisphere, okay? A full piece is a sphere. If you cut it in half, it's a hemisphere. It looks something like this, okay? All right, now that you know how a sphere and a hemisphere looks like, okay, we can get into today's concept, which the objective for today is, okay, our objective is to find the surface area and volume of a sphere and hemisphere, okay. Hint, hint, we're looking for two things, okay, the surface area and the volume of, I wouldn't really say two different items, but a sphere and a hemisphere, okay? It's just the same thing, it's just cut in half. So, the equations we're going to need today, or we're going to be working with today are the one for surface area, okay? Remember, it's area, okay? It's this type of area, 4 pi r squared, okay? So our first equation for surface area is 4 pi r squared, okay? For volume, okay, the equation is 4 over 3 pi r cubed, okay? So 4 over 3 pi r cubed, okay? Now that we know the equations we're dealing with, we can start on today's concept. If I have a sphere, okay, I'm not gonna really redraw a whole sphere again. But if you have a sphere that has the radius, okay, of 6 centimeters, okay, so we have a sphere that has a radius of 6 centimeters. We're going to find both, okay? Because remember, our objective was to find the surface area and the volume of both sphere and hemisphere, okay? So we're starting with the sphere. For our sphere, we're going to find both surface area and volume, okay? So we can use for surface area, we can say 4, you know what, let's do another color here, just so you guys can distinguish the difference. Let's use for surface area, let's use purple. So surface area equals 4 pi r, which in this case our r is 6 squared. So our surface area equals 4 pi 6 times 6, okay, 6 times 6 is 36. Now that we have that, I'm going to multiply 4 times 36. So our surface area equals 36 times 4, which luckily I have a calculator here. We can actually solve it. Again, you can play it like that on the calculator as well. So I'm going to go with 36 times 4, 144. 144 pi So our surface area equals 144 times pi, which is 456 or 452.38. The next one is a 9. So technically, the surface area equals 452 point, only go 2 decimal places after. Let's go with 39 centimeters, because remember, we're dealing with centimeters. Since we're dealing with our surface area, remember, your answer is squared. Okay? Before we find the volume of the sphere, okay, using the same radius, I will say this: since we already have our surface area for the sphere, technically we already kind of found our answer for a hemisphere. Okay, all you need to know is that when you're dealing with the hemisphere, you divide your answer in half, okay, compared to a sphere. Okay, the reason why is, again, remember the ball. If we cut it in half, now we have 2 identical pieces. Okay, since we solved for the sphere, if we want to solve for the hemisphere, all we had to do is cut this in half. Okay, so if we were to divide that by 2, so 452.39 divided by 2 equals 226. So the surface area of a hemisphere, okay, hemisphere, I'm going to put that for abbreviations, and this is sphere, it's 226.195, which technically it becomes 120 or 112 centimeters squared. Okay? Remember, all you have to do is cut it in half to go from a sphere to a hemisphere. Okay? Now that you know that, we apply the same theorem to volume. Okay? So for the volume, if we have 4 over 3 pi r, which our r is already, we're dealing with the same one, 6 cubed. Okay, so v equals 4 over 3 pi, 6 times 6 times 6. That's what 6 to the third power is saying. 6 times 6 is 36, times 6. Oh, wrong one. Let me shift it here. 6 times 6 times 6, 216. Okay, so 216. Our volume equals, again, you can plug it in completely in there, but I'm going to go step by step. I'm going to do 4 divided by 3 times 216, which is 288 pi, which 288 times pi equals, the volume is 904.778, which becomes, the volume equals 904.78. Okay, because we rounded. Again, since we're dealing with centimeters, it's centimeters, but this time we're dealing with volume, so this time it is cubed. Okay. Again, if we were dealing with the sphere, okay, we will cut that in half, the volume, so 904.78 divided by 2 is 452. So the volume of a sphere, or a hemisphere, is 452.39 centimeters cubed. Okay? So sphere, hemisphere. And that's it. We are done. Okay. Remember, the radius never changes. Okay. The only thing that changes is your final answer, depending if you're looking for a sphere or a hemisphere. Okay. I will say this, you're going to have to find both on yours. So I'm going to be expecting 2 answers for each problem for surface area and two for each problem for volume. Okay, 1 for sphere, 1 for hemisphere. Make sure you label it in there like I did for sphere and the hemisphere for which one's which. Okay. All right, make sure you have it on your notes. All right, guys. So here's your assignment for today. You have, for the first one, for both, remember your radius is going to be 5 centimeters. Okay, for your second one, your radius is going to be 12 centimeters. And for your third one, your radius is going to be 8 centimeters. Okay, remember, I'm looking for both surface area and lateral area. But remember, we're looking for also sphere and hemisphere. Okay, so you should have a total of 4 answers for each one of these problems. Okay, remember, 2 for surface area, 2 for volume, 2 for surface area, 2 for volume, 2 for surface area, 2 for volume. Okay. All right, guys. If you have any questions, let me know. As soon as you're done watching the video, make sure you submit your answers. I'll be here waiting for your email.